Describe a binary solar system with one sun-like star and a brown dwarf 5 times larger than Jupiter. Orbital period 2,800 years. A binary solar system typically consists of 2 stars in orbit around a common center of mass. In this scenario, we have a sun-like star, similar to our own sun, and a brown dwarf, which is a substellar object not massive enough to undergo nuclear fusion like a star but larger than a gas giant like Jupiter. Here's a description of the binary solar system you've mentioned. Primary star. The primary star is a sun-like star, meaning it has a similar mass, luminosity, and spectral type to our sun. It serves as the dominant gravitational influence in the system, around which both stars orbit. This star is likely to emit visible light and heat, providing energy to any planets or celestial bodies within its habitable zone. Secondary star. The secondary star is a brown dwarf, a substellar object larger than a gas giant but not massive enough to sustain nuclear fusion in its core. The brown dwarf is approximately 5 times larger than Jupiter, making it a substantial object with a strong gravitational influence on its surroundings. Although it may emit some infrared radiation, it lacks the energy-producing processes that occur in main-sequence stars. Orbital characteristics. The 2 stars orbit around a common center of mass, also known as the barycenter. The orbital period of the binary system is 2,800 years, indicating that it takes this much time for one complete revolution of the stars around their common center. The eccentricity of the orbit may vary and affects the distance between the stars during different phases of their orbit. Potential planetary system. The binary system may host planets in orbit around either or both stars. The presence of 2 stars could lead to complex and dynamic planetary orbits. Planets in the habitable zones of either star would experience periodic changes in illumination and temperature over the long orbital period. Observational characteristics. Such a binary system would likely be detectable through astronomical observations, including changes in brightness and position over time. Advanced telescopes and space observatories would be valuable tools for studying the system and its properties. A binary solar system with a sun-like star and a brown dwarf introduces unique dynamics, and the orbital period of 2,800 years suggests that any planets in the system would experience extremely long and slow-changing seasons. What would be the situation of planet Earth in this binary system? In a binary solar system with a sun-like star and a brown dwarf, the situation of planet Earth would be influenced by the gravitational forces and radiation emanating from both stars. The specific conditions would depend on the planet's distance from each star, the eccentricity of the planetary orbit, and the characteristics of the stars themselves. Here are some general considerations. Dual stellar influence. Earth would be subject to the gravitational forces of both the sun-like star and the brown dwarf. The gravitational pull on Earth would vary as it orbits the common center of mass of the binary system. Orbital dynamics. The presence of the brown dwarf might lead to complex orbital dynamics. Depending on the specific parameters of the binary system, Earth's orbit could be influenced by the gravitational interactions between the 2 stars, potentially resulting in variations in eccentricity and orbital precession over long time scales. Solar radiation. The sun-like star would provide a primary source of solar radiation, similar to Earth's sunday. The intensity of sunlight would depend on Earth's distance from this star. The brown dwarf, being smaller and cooler than a main-sequence star, would emit primarily in the infrared spectrum. While it might contribute some heat to the planetary system, it would not provide significant visible light. Habitable zone. The habitable zone, the region around each star where conditions could support liquid water on the surface of a planet, would be different for the sun-like star and the brown dwarf. If Earth orbits within the habitable zone of the sun-like star, it would experience periodic changes in radiation and illumination due to the binary nature of the system. Long-term climate variations. The binary nature of the system with a long orbital period of 2,800 years would likely result in long-term climate variations on Earth. Changes in stellar irradiance and gravitational influences could contribute to periodic shifts in climate and seasons over this extended orbital period. Stability and eccentricity. the stability of Earth's orbit and its eccentricity would depend on the specific characteristics of the binary system. Gravitational interactions with the brown dwarf might introduce variations in Earth's orbit, influencing its long-term climate and axial tilt. It's important to note that the actual conditions would be highly dependent on the specific parameters of the binary system, and detailed simulations would be needed to understand the intricacies of Earth's orbit and climate in such a system. Additionally, the potential for the presence of other celestial bodies in the system, such as moons or additional planets, would further complicate the dynamics.